Hi everyone, welcome to section 2.7. In this section, we are going to be discussing variation. So variation is a very short chapter section that we are going to be discussing in this section. So what we're going to do is let's start by talking about what types of variations we can have. So we can have direct variation, which is very typical. Direct, inverse, and joint variation. Those are the three types of variation we're going to see in this section. So let's begin by identifying let k be a non-zero constant real number. Then the following statements are equivalent. If you have a direct variation, y varies directly as x. That means that y is directly proportional to x. That means you have y equal k times x because it's directly proportional. So y equal kx. Now this is the direct variation. Now an inverse variation would be y varies inversely as x. So that's the term it says. Or y is inversely proportional to x. That means that y is equal to k over x. So let's write that down. Note that the value of x, k, is called the constant of variation. So what we're going to be doing is we're going to create a variation model using a constant of variation. So we're going to do some examples, and we are going to be using that verbiage, directly proportional or directly as x or inversely as x. So let's look at question 1. X varies directly as y. So it looks pretty much as the first statement, but now it says x varies. So it's x equal k times y directly as y. So then the variables can change all the time. The only one that does not change is the k, the proportional factor. So x equals or x varies directly. That means you're going to be using the first part as y. Now z, it's already telling you the variable z is equal to, it varies inversely as the cube of x. So it's k over the cube of x. So reading between the lines, what does it mean? X is being cubed as the cube of x. So the cube of x is x cubed. Now the next question is t varies directly as w, so k times w, and inversely as q, so divided by q. So first you multiply your constant, the proportional or the constant variation times the w because it varies directly. So directly as w, so it's k times w, and then and inversely as q, sorry. So then divided by q. Now the next question 4 is a little bit more challenging because it's saying a circle's area A varies directly as the square of its radius r. So area A is the circle's area. So normally the area of a circle is pi r squared. But in this case, we don't have pi. We have our proportional factor k r squared. So we don't use pi here. A circle's area A varies directly, so it's k times r squared. So directly, it's the k times r squared. So technically, k is equal to pi in this case. Next question, the electrical resistance R, it's already telling you, R of a wire varies directly at its length. So varies directly, so K times L, and inversely, so divided by, as the square of its diameter, so divided by d squared. So you first multiply it times the length, and then inversely by the square of its diameter, d squared. So all of this is just writing statements between a direct and an inverse variation. What is a joint variation? So a joint variation is let k be a non-zero constant real number. Then the following statements are equivalent. Y, again, remember it can be y, z, t, any variable. let y be, or let y vary jointly as y and x. So now you're multiplying k times w times x. So it's saying jointly, that means you're multiplying by two things, w and x, w and y, x over z. So y is jointly proportional to w and x. That's another way of saying it. So it's y equal k wx, or you're just multiplying it by an additional variable. So looking at question 6, it's saying the rat speed s through the maze varies. So s varies jointly. So it's k times the hunger h and c. So times h times c. So s is equal to k times h times c. Next one up is z varies jointly as x and y and inversely as the square root of p. So z is equal to varies jointly as x and y. So it's k times x times y, but now inversely as the square root of p. So the square root of p. Inversely, every time it says inversely, that means you have to do 1 over the square root of p, or there's going to be something in the denominator. That means that's going to be on the denominator. Whatever the inversely is, that's going to be in the denominator. Now, let's start by identifying what we do when we have applications involving variation. Let's read the question first. It says A varies, so A. So we're going to write a general variation model. A varies directly as B, so K times B, inversely as C, inversely of C. Now the question is saying if A is 20, if A is 20, B is 4, and C is 5, we are going to find K because that's the only variable that's missing. So first we find our constant of proportionality. So let's solve it. So I have 20 is equal to K times 4 over 5. So then we solve for K. We multiply both sides by 5. We get 100 is equal to 4K. K will give me 25. So now I know what my proportion of proportionality is. So now I have A is equal to 25 B over C. Now what happens if I want to find a particular value, find B, when A is equal to 30 and C is equal to 20? Well, let's substitute. So A is 30 is equal to 25 times B, which is unknown, over 20. So first we multiply both sides by our denominator 20. And then we get 600 is equal to 25B. Then we divide both sides by 25. So that gives me that B is equal to 24. So first I have to find K, and then I'm going to substitute K into the original formula to solve for what I'm looking for. And with that, we can start our last question. Let's go ahead and read the question. The volume of a cone is jointly proportional to its height and the square of the radius of the base. Let's write that down. So the volume of a cone, so V, is jointly proportional to its height and the square of the radius of the radius. So K, there's our K, times our height times the square of its radius, so R squared. So that's our first part. Now, what do we know about our constant of proportionality? Because we're looking for a cone, because we have a cone, which is a circular shape, we know that K will be pi over 3. So the general formula for a cone is V is equal to pi over 3 times H times R squared. Now, what if the volume, so first we started with our function. Let's say we did not know that the circular cone of the function was pi over 3. So how would we solve it? The volume, so let's say that we're given the volume is 270 pi. So 270 pi is equal to k times h, where h is 10 and the radius is 9 squared. So you're given h to be 10 and r to be 9. So we substitute it and find k. Let's say that we didn't know k was pi thirds, because on the test you're going to have to find what k is. So then we have 81 times 10, and then we have k is equal to 270 pi. So then we divide both sides. We get 270 pi over 8110 is equal to k. So we simplify this. They're both divisible by 270. So then I get pi over 3 is equal to k. So that was step 1, finding k. Find k with the given values. So the given values was h to be 10 and r to be 9. Now, what is the volume when the height is 18 inches? Now, this is what we're given. What is the height when the height is 18 inches and the radius is 4? So in this case, we don't know v, but we found k. V is equal to pi over 3 times h times r squared. So then h is 18 and r is 4. So now because we found k first, we're able to find the volume. So v is going to be equal to pi over 3, our k that we found from step 1, times 18 times 4 squared. So that's going to be equal to pi over 3 times 18 times 16. So let's punch this in the calculator. 18 and 3, they're both divisible. So this becomes 6. So 6 pi times 16 gives me 96 pi. And this is cubic inches. So the volume of a cone would be 96 pi cubic inches when the radius is 4 and the height is 18. And with that, we would finish question 8 in section 2.7. So we discussed direct variation, inversely variation, and joint variation. And that terminates section 2.7. So you will be able to expect an assignment that incorporates section 2.6, which are inequalities and variation. Thank you, and I'll see you guys next time. Bye-bye.